Hello! Today I will be showing how to do a trig proof with one example. We do trig proofs when we have an equation stating that one trig identity or a combination of trig identities is equal to some other trig identity or combination of identities. And we do this proof to prove that they are, in fact, equal. How do we do this? There are certain rules to trig proofs. One is that you are not allowed to move things across the equal sign, like one might do in algebra by subtracting the same thing from both sides or dividing both sides by the same thing. You can't do that. So instead, we create a table where on one side of the table we have the left side of the equation, and on the other we have the right side of the equation. Once each side is separated onto its own side of the table, we can manipulate each side independent of the other until they are the same at the bottom. And then we can see, oh, this is the exact same as this, so left side is equal to right side. So the original identity must be true.
One way we can manipulate our side of the equation is through using identities that have already been proven to swap out parts of our side of the equation. These can be using simple identities like cosecant is equal to 1 divided by sine, or tangent is equal to sine divided by cosine, or more complicated ones such as the Pythagorean identities or double angle identities.
Some other methods we may use are factoring. On the top here, you may see that both terms have sine in them, so we could factor out sine from the top, leaving tan theta plus 1. And then on the bottom here, this term is squared, and 1 is equal to 1 squared, so we can consider this a difference of squares and factor it as such. So you'd get tan theta minus 1 times tan theta plus 1. And here we now see another step you can take when doing a trig proof, which is canceling out terms, basically, where you're multiplying by tan theta plus 1 on the top, but on the bottom, you're dividing by tan theta plus 1. So these cancel out, and you're left with a simpler identity. And hopefully these could get you closer to the other side, to resembling the other side of the equation. As shown in the previous step, you can divide both the top and bottom by the same value to cancel things out and simplify your fraction. You can also multiply the top and bottom by the same value, in this case the conjugate of the bottom, because that may allow you to simplify your fraction in a further step. The conjugate is if you have something like a plus b on the bottom, or your conjugate would be a minus b, and if you had a minus b, you'd be a plus b. In this case, you would be multiplying by 1 minus cosine on both the top and bottom, which would give you sine theta times 1 minus cosine on the top, and you'd have 1 minus cosine squared on the bottom. Now you could moving forward, you could look to replace this with another value using, say, your Pythagorean identities, and then simplify the fraction by dividing in a later step. But really, sometimes, while it doesn't look immediately helpful, multiplying by the conjugate can get you a little further along, because it can bring you to having a term that is squared, which are often necessary if you want to use your identities. You may also get a fraction adding to some value, or two fractions that are being added or subtracted together. Typically you would like to combine them into one fraction to make them easier to work with. In this case, this has no, it's not a fraction, it's just, if it was a fraction, it would just be divided by 1. So you can just multiply by the base of this one, so that they have the same base. This value is equivalent to cosine theta, but now they have the same base, so you can add them together. And now you're having them on one fraction may make them easier to work with, make it easier to identify anything that you could replace using your identities.
Now for the example equation. The example equation I have chosen to show you is sine theta plus tangent theta is equal to, divided by 1 plus cosine theta is equal to sine of twice theta divided by 2 times cosine squared theta. Now I'll start by drawing a table, placing the left side of the equation on the left side of the table and the right side of the equation on the right side of the table. Typically, it's better to start with the more complicated side of the equation, which would be the left side. But in this case, on the right side, I see sine of twice theta, and there's really only one thing you can do to sine of twice an angle, so I'm going to start on that side. So on the right side here, we can start by replacing sine of 2 theta with 2 times sine theta times cosine theta using our double angle identities. After this, we can divide both the top and bottom of the fraction by 2 times cosine theta, which simplifies our fraction to just sine theta divided by cosine theta. At this point, no more can be done to the right side. It cannot be simplified any further, so I will move on to the left side of the equation. Because I know my final answer must be in terms of sine and cosine only, yet I see tangent on the left side, I believe it is a good first step to rewrite tangent in terms of sine and cosine. Now in the denominator on the left side, I see 1 plus cosine theta, so I believe a good next step will be to multiply both the top and bottom by the conjugate of the denominator, which would be 1 minus cosine theta. This may allow us to replace the denominator with using an identity in our later step. As you can see, both the top and bottom have been multiplied by 1 minus cosine theta. Now expanding, that will give us on the top sine theta plus sine theta divided by cosine theta minus sine theta times cosine theta minus sine theta, and in the denominator 1 plus cosine theta minus cosine squared theta. Now on the top here, we are both adding and subtracting sine theta, so we can cancel out those terms, leaving us just sine theta divided by cosine theta minus sine theta times cosine theta on the top. And in the denominator, we are both adding and subtracting cosine theta, so those will cancel out, leaving just 1 minus cosine squared theta. Now using the Pythagorean identity, we can see that 1 minus cosine squared theta is equal to sine squared theta, so we can replace the denominator, which in this case is 1 minus cosine squared theta, with sine squared theta. Now we can see here that we have sine theta on both the top and bottom of the fraction, so really we could divide this whole thing by sine theta to simplify, just get rid of some of those sine thetas. But I also see cosine theta as the denominator of a fraction on the top here, and we really want minimal fractions, so it'd be best to get that out of the denominator, which we can do by multiplying this whole thing by cosine theta. So dividing by sine theta and multiplying by cosine theta is equivalent to multiplying by sine theta, or cosine theta divided by sine theta, so that's what our next step will be. Now when distributing the cosine theta divided by sine theta, I'll really go through the steps here. On the top here, our first term, sine theta divided by cosine theta, when multiplying by cosine theta divided by sine theta, this just evaluates to be 1. So first term is 1, and then minus sine theta times cosine theta. When you multiply that by cosine theta divided by sine theta, the sine thetas cancel out, and you are left with minus cosine squared theta. Now on the bottom here, you have sine squared theta times cosine squared you have sine squared theta times cosine theta divided by sine theta. Now, sine squared theta is equal to sine theta times sine theta. Now, the dividing by sine theta here will cancel out one of those multiplying by sine thetas, so you're left with sine theta times cosine theta. Now, on the top here, we can once again use our Pythagorean identity, seeing as on the top we have 1 minus cosine squared theta, and as we know, 1 minus cosine squared theta is equal to sine squared theta, so we can now replace that. So now we have sine squared theta on the top, and on the bottom we still have sine theta times cosine theta. So now we can divide this whole thing by sine theta, which on the top, dividing sine squared theta by sine theta, we just are left with sine theta, and on the bottom, sine theta times cosine theta, dividing that by sine theta, we're left with just cosine theta. So this fraction now simplifies to be sine theta divided by cosine theta. And so now, the left side here, we have sine theta divided by cosine theta, and on the right side, we still have sine theta divided by cosine theta. So we can see now the left side is equal to the right side. Therefore, the original equation must be true. So this identity has been proven. And that is a general overview of how to do a trig proof. That is all. Have a good day.